Section 7.6, example 6, performing row operations on a 3x3 augmented matrix to obtain row echelon form. Perform row operations on the given matrix to obtain row echelon form. Okay, so earlier what we wanted in a 2x2 was 1, 0, 0, 1 with our constants over here on the side. That's called reduced row echelon form. So what we're looking for is row echelon form, which is just a little bit different. So in this case, we have a 3x3. Normally our goal is going to be 1, 0, 0, 0, 1, 0, 0, 0, 1 with our 3 constants instead of 2 this time. Very similarly, here we're showing like the X column, we have a solution for X, we have a solution for Y, we have a solution for Z. Perfect, but now we have something that we're calling row echelon form. So we don't care about solving in row echelon form, we don't care about solving the entire matrix. All we care about is solving the diagonal and everything below it. So here we care about the ones where we need it, right here. The zeros below those. Over here, we kind of don't care about what we have in these 3 spaces. And we have some sort of constant over here on the side. So the reason for this is because here we have a solution for Z, which we could plug into this equation here. And with that, we have a solution for Y. So now that we have a solution for Y and Z down here, we're able to plug it into this last equation and find a solution for X. So we're able to do little plugins here and there. So what we really care about is having the ones where we need it and the zeros below it. So step 1, find a 1 in the first column. So a 1 in the top left-hand corner. Oh my, we already have a 1 there. So step 1 is done before we even get started with the problem. Step 2 is to find our zeros here. So to find our zeros, we're using the exact same method that we did with a 2x2. But this time we're going to do 2 steps in 1. I kind of like working with that. So to get a 0 in this space, we're going to multiply our working row. So we're going to call this our working row. So working row, in this case, it's row 1. It's where we have the 1 in it. So our working row, and we're going to use that to find a 0 here. So we're always going to look at opposite or multiply opposite of what we have. So positive to the opposite is going to be -2. -2 times our working row, so row 1. And we're adding that to our manipulating row, which is row 2. And we're doing this for the new row 2. Similarly, we want to turn this into a 0. Opposite of -3 is going to be +3. So we're multiplying 3 to our working row, row 1. We're adding the row we're trying to manipulate, row 3, and we're doing this for the new row 3. So from here, so row 1 is not being manipulated whatsoever. So we are going to just rewrite that one. So 1, -3, 4, and 3. And let's do this one. So 1 times -2 is going to be -2. So -2 plus 2 is going to be 0. And here, -3 times -2, that's going to be a +6. So -5 plus 6 is going to be 1. And we have 4 times -2. It's going to be a -8. 6 plus -8 is a -2. And lastly, for this row, we have 3 times -2. That's going to be -6. -6 plus 6 is going to be 0. All right, so doing that, next we're going to multiply 3 times row 1 and then adding that to row 3. So 3 times row 1. So row 1 is 1. 1 times 3 is 3. 3 plus 3 is going to give us 0, or 3 plus negative 3 is going to give us 0. Now negative 3. Negative 3 times 3 is a negative 9. Negative 9 plus 3 is going to give us a negative 6. Okay, then we have 4. 4 times 3 is 12. 12 plus 4 is 16. And lastly, we have 3 times 3 is 9. 9 plus 6 is 15. All right, so let's take a look at what we have so far. So we had the one where we wanted, perfect. We got these 2 zeros in that last step, perfect. Next, what we want to do is get a 1 in our second column. So we want to get this one. It looks like they're reading our mind because they're kind of doing everything for us. So now that we have that 1 here, reduced our row echelon form, we're going to reduce this to a 0. And so far we have almost half of what we need. Actually, we have more than half of what we need. All right, so goal is to turn this to a 0. And we could easily do that. So what's opposite of negative 6? Positive 6. Which one's our working row now? This one's no longer a working row because we already turned all of these to zeros. This is now our working row. That's what we're going to use to turn everything else into a 0 in that column. So working row is row 2. So 6 times row 2, we're manipulating row 3. So plus row 3. That's going to be for the new row 3. All right, so we're not manipulating row 1. We're not manipulating row 2. So let's just copy those down. And we have 1, negative 3, 4, and 3. 0, 1, negative 2, and 0. And we're trying to fix that one. All right, so we have 0 times 6. That's 0. So 0 plus 0 gives us 0. 1 times 6 is 6. Negative 6 plus 6 is also 0. Perfect. Then negative 2 times 6 is a negative, I lost it. There we go. Negative 2 times 6 is a negative 12. Then negative 12 plus 16 is going to be a positive 4. 0 times 6 is 6. 15, 0 times 6 is 0. 15 plus 0 is 15. And almost done. Let's take a look at what we have. So 1, 1, we have the zeros where we need them. We have a 1 here. We need this one. We don't have that one, but that's a really easy fix. All we have to do is divide by 4, or I don't like using that word in matrix. So we're going to multiply by 1/4. We're multiplying row 3 by 1/4 for the new row 3. Row 1 and 2 are not being manipulated whatsoever, so we're going to just copy those down. Zero divided by 4 is 0. 0 divided by 4 is 0. 4 divided by 4 is 1. And 15 divided by 4 doesn't reduce, so we're just going to leave it as 15 over 4. And there we go. That's our system of equations in row echelon form, where we have diagonals as 1s and everything below them 0s. If you have any questions, please feel free to ask. Otherwise, bye.